Well, here we go again. Section 4.6, corresponding parts of congruent triangles. Corresponding parts of congruent triangles are congruent. This should make total sense, right? If the triangles are congruent, then all of their corresponding parts are congruent. We can abbreviate this as Cpctc. Corresponding parts of congruent triangles are congruent. Let's take a look at how it's used. If you use a congruent shortcut to show that two triangles are congruent, then you can use Cpctc to show that any of their corresponding parts are congruent. Remember, it is important to include a labeled diagram with any proof or explanation. So here's an example. In the diagram, we are given that segment BM is congruent to segment AM, and angle B is congruent to angle A. You can see that this given information is already marked on our diagram. We need to prove that CM is congruent to DM. So let's prove it. We'll start with our given information. I'll use a two-column proof. So I know that BM is congruent to AM, and that angle B is congruent to angle A. And this is all step one, which is given information. Now looking at our diagram, I'm looking for other congruent parts that will allow me to apply one of my triangle congruent shortcuts to prove that the triangles are congruent, and therefore all their parts are congruent. So as I look at this diagram, I can see angles 1 and 2 right here are formed by the intersecting segments CD and AB. Therefore, angles 1 and 2 are vertical angles, and they're congruent by the vertical angles theorem. So, in step 2 here, I'm going to say angle 1 congruent to angle 2 by the vertical angles theorem. For my personal information, I'm going to mark these as being congruent. And the reason I'm doing this is it's going to help me see which triangle congruent shortcut I can apply. Now looking at both triangles, I can see that I have an angle, then a side, then an angle. Looking at the other triangle, I have an angle, then a side, then an angle. So this is going to be the triangle congruent shortcut angle side angle, or ASA. So step 3 of my proof, I'm going to write a congruency statement for my triangles. Triangle ADM is congruent to triangle BCM. And this is because of the angle side angle triangle congruency shortcut. Well, now that I know those two triangles are congruent, I now know that all of their corresponding parts are congruent. So CM, which is a side of my top triangle, will have to be congruent to DM, which is a part of my bottom triangle. So step 4 in my proof is that segment CM is congruent to segment DM by Cpctc. And so there's our first look at how Cpctc, congruent parts of congruent triangles are congruent, can be used in a proof. Let's take a look at another example. The given information here states that angle AEB is congruent to angle BDA. So we see that in our diagram marked here and here. It also states that angle EAB is congruent to angle DBA. And we see that marked here and here. Now we are being asked to prove that segment AE is congruent to segment BD. So we see segment AE here and segment BD here. Now part of doing this proof is deciding which triangles can I prove to be congruent. Well, AE is a part of a couple different triangles. I could see it as a part of this triangle, or I could see it as a part of this triangle. So I have to choose the correct triangles. Well, what if, as I'm looking at this diagram, I see triangle AEB right here, and then I see triangle BDA right here. Now let me draw these two triangles separately so that I get a good visual of what's happening. AEB and BDA. Now let me mark the things that are congruent here. I have this angle, and I have this angle. Then I have this angle, and I have this angle. And when I look at my overall diagram, I can see that this side right here, AB, is part of both of my triangles, AB and AB. So I know that AB will be congruent to itself. So I can mark this as congruent to this. Now looking at my triangles, I have angle, angle, side. Right? Angle, angle, side. And angle, angle, side. So I'm building the argument for my proof. If I prove that these two triangles are congruent by angle, angle, side, then I can conclude that AE is congruent to BD by Cpctc. So let's actually start to write the proof now. So step 1, angle AEB is congruent to angle BDA, and angle EAB is congruent to angle DBA. This is all given information. Step 2, AB is congruent to AB. This is the reflexive property of congruence. Remember, the reflexive property says that anything is congruent to itself. Then step 3, I can now state that I have congruent triangles. So triangle BAD is congruent to triangle ABE. And of course, we know it's very important to write a correct triangle congruency statement where corresponding parts match up. We know that this is true by the angle, angle, side triangle congruency shortcut. Now that we know those triangles are congruent, we can conclude that AE is congruent to BD by Cpctc.